11.7 Mixed expressions and complex fractions. A mixed expression is an expression that contains the sum of a monomial and a rational expression. So in our example, the 2 is the monomial, right? It only has one term. And then the rational expression is this quotient here, right? The 4 divided by x plus 1. So how do we solve these problems right here? Well, we have 2 plus, well, maybe I could do this one first. So how do we solve this problem? Well, what we can do is we can make this monomial here have the same denominator as the rational expression. And how do we do that? Well, you can take the 2 and you can multiply it by x plus 1 over x plus 1. Right? What is x plus 1 over x plus 1? That's just 1, right? So we're multiplying the first term here by 1. And so we can do that, right? Because multiplying any term by 1 is just that same term. So that's how we're going to get the monomial to have the same denominator as the rational expression. So how do we multiply these two guys, right? Well, we can put a 1 underneath the 2, and we can multiply straight across. So over here, the 2 distributes out, so we get 2x plus 2. And then in the denominator, 1 times x plus 1 is just x plus 1, plus 4 over x plus 1. Okay. So now you see by doing this, we have 2 terms that have the same denominator. And so now we can combine, add the numerators together and combine the 2 rational expressions into 1. So we have 2x plus 2 plus 4 over x plus 1. And then if we combine our like terms, we get 2x plus 6 over x plus 1. Right. So that's the strategy there. Let's go ahead and do a couple of examples. We have this one here. What are we going to do? We're going to multiply the 2 by x over x, right? Denominator over denominator. So it's going to be 2 times x over x plus 5 over x. Alright, so how do we multiply 2 times x over x? Well, we can put a 1 under the 2 and multiply straight across. And so we get 2x over x plus 5 over x. Now we have 2 rational expressions that have the same denominator. So we can do 2x plus 5 over x. And you can see we have no common factors. So that's going to be our final answer. So there we go. Okay, so this one gets a little bit more complicated, but it's the same strategy, right? We could say 6y over 4y plus 8 plus 5y times denominator over denominator. Right? So 4y plus 8 over 4y plus 8. So when we go ahead and multiply out, we'll put a 1 under that 5y. And what do we get? We get 6y over 4y plus 8 plus, and now that 5y distributes across, right? So we get 20y squared plus 40y over 4y plus 8, right? The denominator doesn't change because we're multiplying by 1. Okay, so now we have the same denominator, and so we can combine our like terms. Let's say, we can combine the numerators together. So we'll have 20y squared. I'm going to do this in, just try to keep them in standard form. So plus 40y plus 6y, right? So I got the numerator of the second term plus the numerator of the first term over 4y plus 8. So let's see, can we factor anything out of here? We might be able to, but I don't have enough room to get that done. So let's see, if we factor out a 2, then that becomes 10y squared plus 20y plus 3y. Or I'm sorry, we'll factor out a 2y. Yeah, no, that's not going to work out, right? So that's our final answer. And so yeah, we don't have enough room to simplify this further or try to. So we'll just leave it as is, 20y squared plus 40y plus 6y over 4y plus 8. And then, yeah, I guess I should just finish this last one here. So yeah, what are we going to do here? Same strategy, right? We're going to take the second term, the monomial, and we are going to multiply it by denominator over denominator. So x plus 5 over x plus 5, like so. We'll put a 1 underneath the monomial, right? And we'll multiply straight across. So we get x minus 3 over x plus 5. And now here it's a bit problematic. I'm going to put a minus sign because we have binomial times binomial, right? How do we do that when we multiply straight across? Well, we got to use the FOIL method. So we're going to do x times x is x squared. We'll get x times 5. We'll do outside is 5x. We'll do inside. 2 times x is plus 2x. And then the last two terms are 2 times 5. That's 10. Okay. So that's all over x plus 5. Now we'll combine our like terms there. So let me put an equal sign way over here. So we'll get x minus 3 over x plus 5 minus x squared plus 7x plus 10 over x plus 5. So now we can combine our numerators together. And so we'll get the negative distributes out to everybody, right? So it's negative x squared. I'm going to put that one first. And then we'll get negative 7x. Then I have this x over here, so it's going to be plus x. Then the negative 10, right? The negative sign distributes to the 10, so minus 10. And then we have this minus 3. So I think I have everybody. And then I'll say x plus 5. So now we want to combine our like terms. So we'll get negative x squared minus 6x minus 13 over x plus 5. And that's it. Luckily, we don't have enough room, but we would see that we could not factor that numerator there. So we have negative x squared minus 6x minus 13 over x plus 5. So box that.